A pleasant greetings to all. In this video, I am going to explain the algorithm for formation of bus impedance matrix. A simple case of two-bus partial network is chosen for better understanding of the algorithm. However, the modifications are later generalized for large-sized n-bus power system. First of all, I am going to explain type 1 modification. There are 4 different types of modification, the formation of ZBUS matrix. Type 1, Type 2, Type 3 and Type 4. First of all, I am going to explain the Type 1 modification. Adding element ZS between new bus and the reference bus. This is the Type 1 modification. Here one new element is added and also new bus is added. The order of the ZBUS matrix is increased here. What is the performance of two-bus partial network? V1, V2, Z11, Z21, Z11, 12, Z22. So what is the old bus? Old ZBUS is Z11, Z12, then Z21, Z22. Here new element Z is added between this bus and the reference bus. A branch element with self-impedance ZS is added between new bus and the reference bus. Here already the bus in this network is bus number 1 and bus number 2. Here one more bus is added here, that is bus number 3. Bus number 3 is added with the reference bus 0 via the element ZS. Since the added element is a branch, the size of ZBUS increases from 2 cross 2 to 3 cross 3. Okay, what is the new matrix? Already this matrix is the old bus, old ZBUS. Okay, here additional one more bus is added. Now the equation is modified as V1, V2, V3 equal to Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32 and Z33, I1, I2 and I3. Here I am going to find out the diagonal element. To find the diagonal element, I am going to introduce I3 equal to 1 per unit in the third bus. And bus number 1 and bus number 2 are open buses. Okay, from this, what is Z33? Z33 equal to, or V3 is equal to I3 into Z33. What is V3 by I3? That is equal to Z33, that is otherwise known as ZS. So Z33 equal to ZS. Now the modified ZBUS is Z11, Z12, Z21, Z22. This is the old ZBUS old. And what about Z13? There is no element is connected between bus number 1 and bus number 3. That is 0. And Z23 also 0. Z31 is 0. Z32 is equal to 0. And what is Z33? Z33 equal to ZS. This is the type 1 modification. And after finishing the type 1 modification, I am going to write the generalized ZBUS matrix for the type 1 modification. Here the new bus is K and the reference bus is 0. How to write this? For example, K is equal to 3 means ZI3 equal to Z3I. I value is varied between 1, 2, 3 up to N. Here Z13, Z23, Z33. That is equal to Z31, 32 and so on. And what is ZKK? K means 3 Z3. So Z33 equal to ZS. Okay. ZKK having the value remaining all the elements between the buses 1 and 3, 1 and 2. ZKK only having the value. Remaining all the elements in the column as well as row should be 0. This is the type 1 modification. Next I am going to explain the type 2 modification. Adding element ZS between old bus 2 and the new bus 3. Here bus 2 is old and bus 3 is the new bus. The impedance ZS is added between 2 and 3. Okay, already we are having the equation V1 and V2 in the matrix form. So that is equal to what? Z11, Z12, Z13, Z121 and Z22. Here I1, I2. So this is a existing or old Z bus. Okay, what is the new modification made here? See, current is I2 is changed into I2 plus I3. Okay, so that instead of I2, Z11 I1 plus Z212 I2. Here current is new current injected is I2 plus I3. So this I2 is changed into I2 plus I3. In the similar manner, this I2 also changed into I2 plus I3. I am going to expand the equation Z11 I1, Z12 I2, Z13, 12 I2, Z12 I3. Here is Z21 I1, 22 I2, 22 I3. Okay, see, this is the bus number 1 old bus, 2 is the old bus, 3 is the new bus. Okay, this is the old bus. The element is connected between new bus and the old bus. Now see here. Here this is the current I3, this is I2, net current I2 plus I3. Now the current in the second bus is completely changed, that is I2 plus I3. So this is a new current injected in the branch. Now I am going to separate these parts. Here 3 reference and here the voltage V2. Using Kirchhoff's voltage law, I am going to write the equation. So V3 that is equal to the current I3 in the ZS plus V2. Okay. So this is the voltage rise and remaining 2 are voltage drop. Next I am going to substitute the V3. In the V3 equation I am going to substitute V2. So V3 equal to Z121 I1. V2 equal to what? V2 is Z21 I1, Z22 I2. Already we have derived Z22 plus ZS into I3. Okay. And ZS into I3. So combined together. What is the new matrix? Now the matrix order is increased from 2 to 3. Okay. This is the new matrix. The new matrix. What about V1? V1 there is no change. V2 also no change. But what about V3? V3 is changed from here the third one is element is changed. Z21, Z22, Z22 plus ZS equal to I3. What is V1? V1 is Z11 I1, Z12 I2 plus Z12 I3, not Z13. Okay, already we have derived. So these values are 1, 2 and here this is 2, 2. This is the new ZBUS matrix. So this is the new ZBUS matrix for the partial 2-bus network. And next I am going to write the generalized form. To write the generalized form, new bus is K and old bus is J. For example, I have to take the new bus K is equal to 3, old bus J is equal to 2. I is the old buses only, 1 to n. It is varied from 1 to n. Z31 equal to Z21. Okay. And next, Z13 equal to Z31. What about ZKK, Z33 equal to ZJJ, Z22 plus ZS. So this is the generalized form of the equation. Okay, this is the bus new. This is generalized form. Here 1, 1, 2 no. 1, 2 means j is equal to second bus. Here 2, 1 no. 2 is equal. Instead of 2, you have to put j. 2, 2. Here Z plus Z2, 2. Z2, 2 means the old bus ZJJ. And next I am going to explain the type 3 modification. In the type 3 modification, adding ZS between old bus and the reference bus. See, no new bus is added here. One branch is added, but no new bus is added. Already both the buses are already existing. The order of the matrix is not increased. Here, this can be treated as an extension of type 2 modification by introducing new bus 3. The bus 3 is eliminated later by setting V3 equal to 0 by node elimination method. So here already we have obtained the matrix V1, V2, V3. This is the matrix obtained. Current injection method. What is the new current injected? That is I2 plus I3 is the current injected here. Okay. Now, we are having this new diagram. Here I am going to put V3 equal to 0. V3 equal to 0 means it is short circuited, directly connected to the reference. Already we are having V3. Now V3 is 0 means the current is flowing. There is no voltage in this place. It is short circuited. So V3 in this equation, I am going to put V3 equal to 0. So V3 equal to 0. So V3 equal to what? Is it 21 I1? Is it 22 I2? It's a 2 plus is it 3 into I3. From this, I am going to put V3 equal to 0. From this, what is I3? I3 equal to is it 22 plus is it yes into I3, that is equal to is it 21 I1 plus is it 22 I2. This is minus. And afterwards, I have to find out I3, that is minus 1 by Z22 plus ZS into Z21 I1 plus Z22 I2. Okay, this is the equation for I3. Okay, next I am going to take the equation V1. V1 is the equation. In this equation, I am going to put the value I3. Okay, so V1 equal to what? Z11 I1, Z12 into I2 plus Z13 into minus 1 by Z22 I plus ZS, Z21 I1, Z22 I2. Both the equation Z12 is common. I have to take Z12 outside. So inside I2 minus this value. Afterwards, I have to combine this Z11 minus Z12 into Z21 divided by Z22 plus ZS into I1 plus Z12 minus Z12 into Z22 divided by Z22 plus ZS into I2. Okay, in the similar manner, I have to take the equation V2. I am going to apply the I3 in this equation. Okay, now I am going to expand this. So V2 is Z21. Here one I1 is there. Here also we are having I1. Z22 into Z21 divided by Z22 plus ZS into I1 plus Z22 minus Z22 into Z22 divided by Z22 plus ZS into I2. This is the equation V2. Equation F and G can be written in the matrix form. So first Z11, Z21, Z12, 22, I1, I2, you have to separate those. And afterwards 1 by Z22 plus ZS. So inside we are having this matrix. And what is the next? Here Z22 plus ZS. I have to take Z12, Z22 here. And Z21, Z22. Now you have to multiply the same equation you have to obtain. Z12, Z21, Z12, Z22, Z22 into Z21, Z22 square into I1, I2. So this is the ZBUS new. Now take I1, I2 as a common. So Z11, Z12, Z21, Z22. So this is the old bus, old Z bus old. And this is the equation I am going to find out. Okay, this is the equation for Z bus new. You have to find out this equation, and this equation is subtracted. First find out this. This is subtracted from Z bus old. Okay, that the equation can be written as the most generalized form. Assume the element of self-impedance Z is added between old bus K and the reference bus in the n-bus partial network, and old bus is K no. So what I have to do, 1, 1, 3, 2, 3 and so on. And here old bus K is for example, I have to consider the old buses too. So Z12, Z22, Z21, Z22 and so on. This is generalized form of the equation in I-val. So, okay. Generalized form of the equation. So next I am going to explain type 4 modification. Adding element ZS between old bus 3 and the old bus 2. So this is the type 3 modification. Or branches added between two old buses only. So here also there is no need of increasing the size of the matrix. Okay, see, this is the new diagram. Here this is the partial Z bus or 2 bus matrix. This is a known matrix, and 2 and 3 are connected via the element ZS. Here number 1, the current is flowing I1, 2, 3 and reference. 2, the current I2, and here the current is I3. This I3, one of the current I have assumed as I4. So whatever the current is flowing in the network, I3 minus I4. So new current injected in the branch in the bus I3 is I3 minus I4. And new current is injected in the bus 2 is I2 plus I4, because this is the current I2, this current I3, both the currents are combined together. Okay, now I am going to write the new bus. Already I am having I1 and this one is I3 and I2 and I3. New I2 is I2 plus I4, new I3 is I3 minus I4. Okay, next I am going to separate this diagram only using the bus number 3. So 3, and here the voltage V2, here the current I4, and I have to put the value here. Next I am going to write the equation V3 is it is I4 plus V2. The voltage of the buses 2 and 3 can be written in as. What is V3? V3 from this I am going to write V3 is a 3 3 I1 is a 3 2 I2 minus plus I4 is a 3 3 I3 minus I4. That is equal to put the value of V2 also. V2 is what? Is a 2 1 I1 is a 2 2 I2 plus I4 is a 3 3 I3 minus I4. Okay, is a 2 3. Is it as plus I? Is it as into I4? Rearranging the above equation. So how to rearrange this? So rearranging the above equation. So here see Z31 and Z21. Z21 minus Z31 in the I1. Here Z22 minus Z32 in the I2. Then Z23 minus Z33 into I3. So remaining elements all are multiplied with the current I4. So I4 of Z22 here Z22, yes, here ZS plus here is minus Z32, then plus Z33 and minus Z23 equal to 0. What is I4 now? I4 equal to minus 1 by Zx. Here I have to take this as Zx. Zx into this value. Or Zs is Z22 plus Zs minus Z23 minus Z32 plus Z33. Then I4 is written in matrix form. How to write the I4 in matrix form? First write 1 by Zx. Then write first element Z21, Z31 in the I1. So because you have to take the transpose. Then only you have to multiply these two values. Okay. Z22 minus Z23 into I2. Z23 minus Z33 into I3. So after finishing this, separating I4 terms in this equation. See in this equation, V1, V2, V3, Z1, Z2, Z13, Z21, Z23, Z31, 32, 33. Okay, see this Z12 is associated with the current I4. Z13 into minus I4. So how to write the Z12 minus Z13? And Z22 minus Z23. Z32 minus Z233 into I4. Substituting the value of the equation I4. So what is I4? I4 is the transpose of this into I1 into I3. Okay, what is ZBUS new? This is the ZBUS old. And this is the value we are going to find out. Okay, the equation can be written in more generalized form. I and K both are the old buses. So how to write this? 1I minus 1K. For example, I is equal to 2 and K is equal to 3. So 1, 2 minus 1, 3. Z2, 2 minus Z2, 3. Then in the similar manner, you have to finish the remaining also. So how to write Zx, Zxs, Zss plus Zii. Instead of Z22, I am going to put Zii. Instead of Z33, I have to put Zkk. And instead of Z23, that is Ik, Z32, Ki. So this is the value of Zx. This is a generalized form of the ZBUS matrix. Thank you. Have a nice day.